Good morning, everybody. We're kind of wrapping up content for electricity and wanted to make sure we went through what popped up in a couple of problems, which are combination circuits or combo circuits. Those are circuits that have elements that are connected in series and elements that are connected in parallel. So for the circuits we got right here, R2 and R3, if you had those just on their own, they look like they're in parallel. So we would need to treat them as a parallel circuit connection. And over in the second example, R2 and R3, well, they look like they're connected in series. But there's also a branched off circuit element here in R1, so there's a combination of connections here. So we're going to go through the steps of how to solve those combination circuits and get the total resistance. And once you know how to get the total resistance of a combination circuit, you can calculate what the current coming out of the battery is. You can calculate the power consumption of the whole circuit. You pretty much then have a resistance and a voltage and a current you can work with and do anything. So we just need to take a look at what we're going to do step by step. So first off, if we take a look here, get my cursor going. In order to find that total resistance, we have to do it in multiple steps. And in this case, with only 3 resistors, we only have to do 2 calculation steps to find the total resistance, because 2 of those resistors are going to be connected in series or parallel to each other, and then whatever that combination is, whatever that total resistance is for those first 2, it's going to be in series or parallel with the third resistor. So we just do it as kind of staggered steps. So the first step is to find the 2 resistors that are farthest away from the battery. And in the case of what we've got up above, that first picture, the R3 is the resistor that's farthest away from the battery, and then R2 is the next closest. So those 2, I want to circle them and decide, are they in series or in parallel? Well, R2 and R3, they're in parallel to each other. There's 2 different pathways. So I would find the total resistance of those 2 resistors in parallel using the inverse addition equation. Then, after I've got that, I'm on step 3 already. After I do that, I take whatever resistance I got there and I extend my bubble to include the next resistor, the next closest to the battery, and decide is that in series or parallel with what I just calculated. So if I've got R2 and R3 and they were in parallel and I calculate them as a number, that total resistance that I got highlighted in yellow, that's in series with R1, because any charge that goes through R1 has to go through whatever that yellow circled object is. So it's in series. Series means you have to go from one thing to the other in a row. So R1 is in series with whatever the R2 and R3 were together. And we'll draw that down below for some calculations. Then you're done. Once you've got that, you've got 2 steps of calculations completed, and you can go from there. So let's take a look at, erase those bubbles. If we take a look at the second picture here, we've got the farthest away resistors are R2 and R3, and are those in series or in parallel? Yeah, they're one after the other. That's a series connection, so I would just add those 2 resistors together. Then, once I get a number there, I say that all that is connected to R1, and that is parallel connection. R1 is in parallel with whatever R2 or R3 make up. So I would do parallel calculations from there. So take a moment to digest that, and let's go ahead. Actually, I'll just leave that up there. I undid all my things. So got that. Those 2, we then connect to this guy. There we go. So let's go ahead and take a look at these 2 circuits here as example problems. So example 1, I'm taking the first picture and I've turned it into all 10 ohm resistors. And I need to follow my steps there. Find the resistors that are farthest away from the battery. So in that case, it's going to be those 2 dudes right there. And those 2 resistors are in parallel with each other. So my first calculation step is to calculate the parallel resistance of those 2. So our total for a parallel connection, we're going to do the whole -1 powers, would be 10 to the -1 plus 10 to the -1 all to the -1. And you can do the whole fraction thing. which you would write as R total is equal to 1 over 10 plus 1 over 10, and then all that to the negative 1. You decide how you want to work it out. I prefer using the negative 1 powers. And if I do that, I should get 5 ohms. So everything that's in yellow there is equivalent to just being 5 ohms. Now, the next step is to find the next resistor, the third resistor in the circuit, and include that and decide if it's series or parallel. Well, let's go ahead and redraw this. Let's reevaluate what this circuit looks like. I've got some battery. I've got that 10 ohm resistor at the top. And now where that yellow circle is, I'm going to replace it with just that 5 ohm resistance. I don't have a 10 and a 10 in parallel. It's equivalent to just having a 5 ohm resistor there. So I've got the 10 ohms and I've got 5 ohms. So that should make it a little bit easier for you to do step 4, where you decide, is what I just calculated in series or is it in parallel? And this is clearly in series. So I'm going to go ahead and highlight in yellow what I calculated there. And now for step number 4, I'm going to highlight in blue these two resistors, and their R total, which is going to be the R total for the whole circuit, will just be 10 ohms plus 5 ohms, which gives me a total resistance on the entire circuit of 15 ohms. Now I could use that to calculate what the current in the circuit is. If I knew what the current was, I could use that to calculate what the battery voltage was. Once I know those two things, I can calculate what the power is. I'd say that it's limitless possibilities, but you're limited to like 3 or 4 things. Let's do the same steps again, but trying it on the other picture that I had down below here. Now, what I want to do is determine for the 2 farthest away resistors, are those series or parallel, calculate their value, then include the next resistor and decide, is that resistor, sorry, I had something baking here, turn that off. Some frozen frittatas that we're cooking up. It's a lockdown cuisine right here. Okay, back to work. So for, and I'll eat those frittatas later. For the second circuit, let's go ahead and do the same sort of steps. We got the first 2 resistors there, our first the 2 that are farthest away from the battery. We want to isolate those and basically want to simplify the circuit step by step by step. It's tempting for someone to look at this and say, well, why don't I say this 10 and that 10 are in parallel with each other? And oops, that was the wrong button. Like, why don't I say that those 2 are in parallel? Doesn't that make sense? Well, no, because any charge that gets to that point right there does have to split and go between either this 10 or that 10, but this branch of the circuit is what it's going through, not through any single resistor. So a charge that gets to that split has to go through an entire branch or another entire branch. So we have to look at each total branch together. We don't look at it in terms of just pick 2 resistors and calculate what they are. So we'll do the 10 ohm and the 10 ohm that are farthest away from the battery. If we look at those appear to be in series. So their total resistance is just going to be the sum of the 2, which would be 10 ohms plus 10 ohms gives us 20. And then I can do what I did on the last circuit, which is, let's go ahead and redraw it, but I got some space, so I'll draw it down below. I can say that this whole circuit now essentially looks like this. I got the 10 ohm, and now I've got 20 ohms. Sorry, drawing is very poor. I'm hungry. I want some of those frittatas. So that 20 ohms came from the 2 that were in series with each other. Now I'll take a look at including the next resistor over. So I've got the 20 ohms that are there, the 10 and the 10. Now this guy is in parallel with the 20. So from those two, I can calculate a total resistance for the entire circuit. So that would be 10 to the negative 1 plus 20 to the negative 1, all to the negative 1 power. I don't know what that is, so I'm going to grab my calculator here. 10 negative 1 plus 20 negative 1, all that to the negative 1. I get 6.67, or 6.7 ohms. So in this case, the total circuit has less overall resistance than it did when those same three resistors were hooked up in a different orientation. And that's just the way it goes. But now that we have that answer, we can again calculate power, calculate current, voltage, whatever is required of us. So hope that was helpful, and I'll see you around.